Hi, I'm Swarupa Sahil, course instructor for Geotechnical Engineering 1. In this presentation, we will go through interpretation of consolidation test results. When a coarse-grained soil, that is granular soil, is loaded, maybe due to construction of structure, then the settlement is instantaneous. The total settlement of soil is sum of elastic settlement, primary consolidation and secondary consolidation. For granular soil, primary consolidation and secondary consolidation is 0. Hence, elastic settlement is the total settlement of the soil. By looking at the graph of settlement versus time, we can see that the settlement is instantaneous. But when a fine-grained soil, that is saturated clay, is loaded, water is removed from the voids over a longer time, as permeability for clay is low. Hence, settlement occurs over a long time, which can be for several years. When we look at the graph of settlement versus time, we can observe that settlement gradually increases and it will take maybe months or years. And when we have a look at the equation to find total settlement, we observe that the elastic settlement is negligible, whereas primary consolidation and secondary consolidation is significant. Following consolidation properties of a given soil are determined. First one is coefficient of compressibility, which is denoted by AV. Next is coefficient of volume change, denoted by MV. Then coefficient of consolidation, denoted by CV, which gives us the rate of consolidation. Next is compression index, denoted by CC, which gives us the magnitude of settlement. Then is recompression index, denoted by CR. Then is pre-consolidation pressure, denoted by PC. Coefficient of permeability, denoted by K. And time required for consolidation, which is also referred to as consolidation time, and it can be found using equation TH square divided by CV, where T is the time, H is the thickness of the sample, and CV is rate of consolidation. Now we will find out how to get the value of first term, that is coefficient of compressibility, denoted by AV. Final void ratio E for every loading is noted down during the test. Then a graph of E versus sigma V dash, which is vertical effective stress, is plotted. So here we can see a graph which is drawn for E versus effective stress. As load increases, we can see from the graph that void ratio is decreasing. And when load is removed, there is only partial restoration. And AV is defined as the decrease in void ratio per unit increase in pressure. So we can write equation for AV as minus delta V divided by delta sigma V dash. So here along this curve we will choose 2 points in order to find AV. Delta V is the difference between void ratio. Suppose at 2 points, if we consider voids ratio, that is at 0.8 and 1.2, so delta E will be 1.2 minus 0.8. Similarly, to find sigma V dash, that is change in effective stress, we will mark corresponding effective stress for the voids ratio which we have considered. So that is 100 and 200. So difference between these two values will give us sigma V dash. So once we substitute delta E and delta sigma V dash, we will be able to get the value of coefficient of compressibility. Negative sign indicate the decrease in void ratio with an increase in pressure. So coefficient of compressibility is a measure of compression of the soil mass. We know that as load on the soil increases, there will be removal of water from the voids. Hence, there will be decrease in void ratio, due to which soil compresses. The unit of coefficient of compressibility is centimeter square per gram.